Hello, so I am Ankur Bansal and I'm here for the subject process dynamics and control, and today we will discuss about the basic introduction of the subject process dynamics and control. So in this subject, first of all, we'll discuss about the process dynamics part. Process dynamics. Now, one and the most important basic misconception about this subject is many of the chemical engineer does not feel this subject as the technical subject. Means many of the engineers say that mass transfer, fluid mechanics, chemical reaction engineering, heat transfer, thermodynamics are the most important and the core subject of the chemical engineering, while process dynamics is just like the subject of electrical and instrumentation, and it's out of the core. But I want to clarify this. I want to give a brief introduction about this, that no, process dynamics is the most important subject and it is the most important core subject also, because the knowledge of other subject will help you to apply the material balance, to apply the momentum balance, but to arrange all the types of equation into a model. For that, what we require is process dynamics. For example, let us take an example of distillation column. Now in the distillation column, we know that there are first of all number of trays, feed comes up, then there is a reflux drum before the condenser, then there is a reflux, the top product, reboiler, and the bottom product. Now this is the distillation column that is already installed in the industry. Let's say I want to open my new industry, and for that I want to purchase the distillation column. So we'll go to a chemical engineer and we'll ask him to design a new distillation column for my project. Now to design a new distillation column, there are basically two options. One of the option that is used previously, which is on the based on the lab scale, that we will set up a pilot plant, and in this pilot plant we will do certain experiments to generate the data experiments, and based on these experiments we will collect some data, and after collecting the data we will optimize the data so that we can determine the optimal point at which we will design our distillation column. Now optimal point is what point? Optimal point is that point at which the cost is minimum and the profit is maximum. That is known as optimal point. That is lab scale. Time is required in doing the experiments. Many errors are there as experiments are carried out, and during optimization calculation is required. So it is time taking, money taking, and not error free. But on the contrary side, the other method is known as modeling and simulation. Now what happens in modeling and simulation, that first of all there is no need of physical pilot plant. What we require is a model. Now what is a model? Let us understand this distillation column again. That is a physical distillation column, but What we can do, we can apply the material balance equation. What we can apply the heat balance equation. What we can apply the equilibrium relationships. And what we can apply the summation equations. So this is the group of equation that we can apply for the distillation column, and these are also known as mesh equations: material balance, equilibrium, summation, and the enthalpy. Mesh equations. And when we have a number of equations, let us say there are n number of equations. Now what will we do? We'll count the number of variables. Let's m is the number of variables. And number of variables minus number of equation will give us degrees of freedom. So what is the ultimate task of a chemical engineer is to nullify the degree of freedom and equalize it to 0. For that, what I need to do is to increase the number of equation or to define some of the variable. Define some of the variables. So it is very difficult to increase the number of equation, and that's why what we do, we define some of the variables. Like feed is defined to us, feed mole fraction is defined to us, distilled mole fraction defined to us, bottom product mole fraction defined to us. So these are some of the things that are defined. Ultimately degree of freedom becomes 0, and when it becomes 0, then we have a model. So that's how we prepare a model. And similarly, for each and every equation, for each and every equipment, we can apply a set of mathematical equation which together constitute a model. And when we have a model, what we do, we change input, and as we change input, what will happen? Output changes. So what we get? We get a set of values. And this set of values is then optimized to get optimal point. So this is the way of modeling and simulation, that we prepare the model by the help of some mathematical equation, then we will provide degree of freedom as 0, we will define some variables, then we change the input to change the output, then we get the set of values. These values, or you can say data points, these data points are then optimized. Now how to optimize? Very easy, just multiply the data points with cost data. Cost data, that means we know what is the ultimate feed of cost of raw material, that is feed, what is the selling price of my distillate, etc., what is the cost of maintaining the temperature, what is the steam given to the reboiler, what is the heat taken from the condenser, etc. We know the cost. So we multiply the data points with the cost, we get the cost data, and ultimately the point at which the cost is minimum and the profit is maximum, at that point we design the distillation column. So what do you think now? If process dynamics knowledge, modeling and simulation knowledge is not there, then how to design some equipment? To design an equipment, we need the optimal point, we need to minimize the cost, We need to maximize the profit, and that is possible only when we know how to model, when we know how to simulate, and when we know the knowledge about the economics part also. So chemical engineering is not just the study of fluid mechanics, heat, mass, etc., but it also requires the knowledge of modeling and simulation along with the knowledge of economics, so that we can convert the raw materials or the raw goods into the finished products at the minimal cost. So yes, process dynamics is very important for the chemical engineers, and it is the most important subject of ours. Thank you.